Hello students, last session we have discussed about simple machines. This class we will be discussing about one type of simple machine called pulleys. Okay, all of you are familiar with pulleys. It is a simple machine, right? A pulley is a simple machine which is commonly used to lift heavy loads. A pulley in its simplest form consists of a disc. The diagram you can see the disc. The disc is made up of wood or metal. Okay, the disc may be a metallic disc or a wooden disc. And the disc has a grooved rim around its circumference. And a rope is made to pass over the grooved rim of the pulley. This disc can rotate about an axle. At the center you can see the axle. This disc can rotate about an axle passing through its center. The axle is rigidly fixed to the frame by means of two pins. In the diagram you can see that the axle is fixed to the metal frame by means of two metallic pins. Okay, and the pulleys are used either as a single one or it can be used in combination. Okay, so this diagram shows the disc portion of that is the pulley. Okay, the diagram you can see that the metal frame, the disc, then the grooved rim which is surrounding the circumference of the disc, and the metal frame is fixed to the axle by means of two pins. Okay, and the metal frame is fixed to the rigid support. Okay, and a single pulley can be used in two different ways. One is as a fixed pulley or it can be used as a mobile pulley. The fixed pulley means the rotational axis remains fixed. This, in the case of single fixed pulley, the axis of rotation remains fixed. That is, it becomes stationary. Yes, then it is called as the axis of rotation of the pulley is fixed or stationary in position. Then it is called as the fixed pulley. Yes, and first we discuss about the single fixed pulley. This diagram shows the single fixed pulley. In the diagram you can see that a metallic disc, a rope is made to pass over the grooved rim of the pulley. One end of the rope, the load to be carried is suspended. The other end, the effort is applied in the downward direction. The metal frame is suspended from the rigid support. Yes, here the frame of the pulley is fixed to this frame of the pulley is connected to the rigid support. A light and an inextensible string passes around the grooved rim of the pulley. The load L to be lifted is connected to one end of the string and the effort E is applied at the other end of the string. You can see in the diagram. Here the effort is applied at the other end of the string. The load L as well as the effort, here effort as well as the load, if you see, both are acting in the vertically downward direction. The effort is acting in the downward direction like this. The load is also be acting in the downward direction. Both load and the effort are acting vertically in the downward direction. When the string is pulled downwards by the effort, when the string is pulled downwards by applying the effort, the load L moves upwards. So the tension T is developed in the string in the upward direction. So in this segment of the string where the load is suspended, the tension will be acting on the string in the upward direction. The string where the effort is applied, the segment of the string where the effort is applied, there also the tension will be acting in the upward direction. Since we have taken the inextensible light string, so what happened? The tension acting along the entire length of the string will remain the same. The tension acting on the string will always act in the opposite direction, the upward direction. The tension will always be acting in the upward direction, which I have indicated by an arrow mark. Okay. Next, we calculate the mechanical advantage of this pulley system. So the diagram shows this single fixed pulley. Yes, in the diagram, you can see that metal disc. Yes, and the frame is connected to this connected to the rigid support. The rope is made to pass, inextensible string is made to pass over the grooved rim of the pulley. One end of the rope, the load to be lifted is connected. The other free end, the effort is applied. Both effort and load are acting in the downward direction. When you apply the effort to pull the string in the downward direction, the load will be lifted in the upward direction. And here we have to calculate the mechanical advantage of this single fixed pulley. Mechanical advantage of the single fixed pulley. Suppose if you consider that the string is light and there is no friction, that is we are neglecting the friction acting on the axle of the pulley, and the string is, we consider the string to be very light, then in equilibrium condition, the load L acting on the string, the load L which is acting in the downward direction is balanced by the tension acting on that segment of the string in the upward direction, and the effort which is applied at the other end of the string in the downward direction is balanced by the tension acting on that segment of the string in the upward direction. That is, the load is balanced by the tension T acting on that segment of the string in the upward direction. The effort applied in the downward direction is balanced by the tension acting on that segment of the string in the upward direction. We know that the expression for mechanical advantage is load by effort. Here load is equal to T, effort is also equal to T, which is equal to 1. So the mechanical advantage of this pulley system we have calculated as 1. So we can say that in an ideal condition, yes, the mechanical advantage, that is the load to be lifted is equal to the effort applied. So the mechanical advantage we have calculated as 1. But in an ideal condition, one has to apply an effort equal to the load to be raised. Only in ideal condition, the effort applied is equal to the load. But in actual practice, some friction is always present at the axle of the pulley. Hence, effort applied should be slightly greater than the load. Only in ideal condition, the effort applied is equal to load. But in actual practice, definitely there will be a friction in the axle of the pulley. So, the effort applied is always greater than the load. The effort is applied not only to overcome the load, but also to overcome the friction in the axle of the pulley. Okay. Next, we calculate the velocity ratio. So, from this we have calculated the mechanical advantage. Okay. Here the mechanical advantage is equal to 1. Yes. Next, we calculate the velocity ratio. So, the velocity ratio, if we take by applying the effort moves through a distance dE, and which makes the load to displace through a distance dL. Yes, if the displacement of the effort is, the displacement of the effort dE is equal to D, then the load also will undergo the displacement equal to that of the displacement of the effort. Then dL is also equal to D. From definition, we know that velocity ratio is equal to displacement of the effort by displacement of the load. So, if you substitute here, velocity ratio is equal to d by d, which is equal to 1. So, velocity ratio is also equal to 1. Yes. So, this pulley, if I calculate the efficiency, we know that efficiency is equal to mechanical advantage by velocity ratio. This is the relation connecting mechanical advantage, velocity ratio and efficiency. Here, according to this, we have calculated mechanical advantage as 1, velocity ratio as 1. So, the efficiency is equal to 1 or 100%. Yes. This is possible only in ideal condition. Okay. Once again, I repeat, students, here we have derived the expressions for mechanical advantage, velocity ratio and efficiency. Mechanical advantage, from definition we know that mechanical advantage is equal to load by effort. In the single fixed pulley, the load is balanced by, the load which is acting in the downward direction is balanced by the tension acting along that segment of the string in the upward direction. The effort applied at the other free end of the string is balanced by the tension acting on that segment of the string in the upward direction. So, load L is equal to T, effort E is equal to tension acting on that segment of the string. Mechanical advantage is equal to load by effort, L is equal to T, E is equal to T. So, mechanical advantage is equal to 1. Yes, that is this is in ideal condition. That is, in ideal condition, the effort applied is equal to the load to be lifted. But in actual practice, if you see that, definitely there will be some friction in the axle of the pulley. So, the effort applied will be, effort applied is not only to overcome the load, but also to overcome the friction in the axle of the pulley. So the effort applied is always greater than the load to be lifted. Okay. Next one, velocity ratio. If we take dE is the displacement of the effort, that is the effort moves through a distance dE and which makes the load to undergo the displacement dl, then the velocity ratio is equal to, that is the displacement of the effort is equal to how much distance the effort is moved, the same distance the load will be moved in the upward direction. So if the displacement of the effort is equal to d, then the displacement of the load is also equal to d. So substitute in velocity ratio expression, we will get velocity ratio is equal to 1. Okay. Then from definition we know that the relation connecting the mechanical advantage velocity ratio is eta efficiency is equal to mechanical advantage by velocity ratio. Here we have calculated the mechanical advantage as 1, velocity ratio is also equal to 1, substitute we will get the efficiency is equal to 1. Normally the efficiency is calculated in percentage, so if you multiply by 100 we will get the efficiency is equal to 100%. Okay. Now let us discuss what are all the advantages of this system of pulley. The main advantage, if you see that here the single fixed pulley, it is not acting as a force multiplier. That is, by using this pulley we are not obtaining any gain in force. How? See the value of mechanical advantage. Mechanical advantage is equal to 1. Then if the mechanical advantage of the machine is equal to 1, by using that machine we don't get any gain in force, we don't get any gain in speed. By using the machine to obtain gain in force, the mechanical advantage should be greater than 1. To obtain gain in speed, the mechanical advantage of the machine should be less than 1. But in this case, single fixed pulley, the mechanical advantage is equal to 1. That means by using this pulley, we are neither obtaining gain in force nor gain in speed. That is, this single fixed pulley neither acts as a force multiplier nor as a speed multiplier. Then what purpose we are using this pulley? This pulley is employed simply to change the direction of the effort applied. You know that by using this pulley, you are applying the effort in the downward direction, that is along the force of gravity, which is convenient. Suppose if you are not using the pulley, you have to pull the weight in the vertically upward direction, that is against the force of gravity, which is inconvenient. Yes. So by using this pulley, you are applying effort, you are changing the direction of application of the effort. Yes, that is in the downward direction. Yes. So this pulley, advantage of this pulley is you are applying effort in the downward direction. We are not obtaining any gain in speed, we are not obtaining any gain in force by using this pulley, but we can apply the effort in a convenient direction, that is in the downward direction. That is the advantage of this pulley system. Next we pass on to single mobile pulley. Single mobile pulley means the pulley whose axis of rotation is mobile. Okay, the axis of rotation is not fixed, but it is mobile. The diagram shows the single mobile pulley. In the diagram you can see that here one end of the light string is connected to the rigid support. In the diagram you can see the one end of the light string is connected to the rigid support by tying it to the hook. The string passes around the mobile pulley and the effort is applied at the free end. You see that the effort is applied at the free end, but it is in the upward direction. The string passes around the mobile pulley. Yes, the load to be lifted is joined to the frame of the mobile pulley. See the center one, you can see the frame. The load to be lifted is joined to the frame of the mobile pulley. Yes, and the load is acting in the downward direction. Put arrow mark in the downward direction. Yes, when the pulley is pulled up by this effort, the effort is applied at the free end. When the pulley is pulled up by the effort E, the tension D is developed in both segments of the string. There are two segments you can see in the diagram. The tension will be developed in both the segments of the string, and yes. So here the single mobile pulley whose axis of rotation is, which the pulley is mobile, whose axis of rotation is not fixed. Here the light string is connected to the hook of the rigid support. The other end passes over the grooved rim of the mobile pulley. The other free end you are applying effort in the upward direction. When the effort is applied, it is balanced by the tension acting on the two segments of the string. The load is in the diagram, the load is connected to the frame which is fixed at the center of the pulley. Yes. Next we calculate the mechanical advantage of this pulley system. So the mechanical advantage of this pulley system, to calculate the mechanical advantage of this pulley system, we say that since the load is attached to the frame, the load is balanced by the tension acting on the two segments of the string. The tension T is acting on one segment of the string and the tension acting on the other segment of the string is also T. So the tension acting on both the segments of the string are balancing the load. So L is equal to T plus T, which is equal to 2T. And the effort is balanced by the tension acting on that segment of the string in the upward direction. So the mechanical advantage expression is load by effort. Yes, here load is equal to 2T, effort is equal to T. So the mechanical advantage is equal to 2. Yes, this case once again I will derive it. Yes, the calculation of mechanical advantage of this single movable pulley. The load is balanced by the tension acting on the two segments of the string, which is equal to 2T. The effort is balanced by tension acting on that segment of the string where the effort is applied. We know the expression for mechanical advantage as load by effort. Yes, load is balanced by 2T, effort is T. So the mechanical advantage of the single mobile pulley system is equal to 2. Yes, so mechanical advantage is equal to 2 means this pulley system will act as the force multiplier. When the mechanical advantage of the machine is greater than 1, then the machine acts as the force multiplier. That means by using the single mobile pulley, we are obtaining gain in force. The single mobile pulley acts as the force multiplier. Next, we derive an expression for the velocity ratio. Yes, so we calculate the velocity ratio for the single mobile pulley. If the effort E pull up the free end of the string by the distance D, yes, that is the displacement of the effort is D. The effort applied on the free end of the string, move it by the distance D. Then the segment of the string on each side of the pulley moves up by a distance. This distance is shared by the two segments of the string. So each side of the pulley moves up by a distance D by 2. So the load is raised by the distance, that is the displacement of the load is equal to D by 2 because both the segments of the strings are sharing this displacement. So the load is displaced by the distance D by 2. Now, in the expression for velocity ratio, we know that from definition it is displacement of the effort by displacement of the load. Displacement of the effort is D. Displacement of the load is D by 2, which is equal to 2. So, the velocity ratio of this pulley system, single mobile pulley, is equal to 2. Yes. Next, efficiency. So, the efficiency is equal to mechanical advantage by velocity ratio. Here we have calculated the mechanical advantage as 2, velocity ratio as 2. So, the efficiency of this single mobile pulley is 1 or 100%. Yes, and here the mechanical advantage is greater than 1. So, by using this pulley we are obtaining gain in force. But there is a disadvantage of using the pulley. Though this single mobile pulley acts as the force multiplier, the main disadvantage of this pulley is the effort is applied in the upward direction, which is inconvenient. Okay. So, if you compare the single fixed pulley and the mobile pulley, the single fixed pulley, by using it we are not obtaining any gain. There is no gain in speed, no gain in force. But by using this pulley you can apply the effort in the convenient direction, that is the downward direction. But by using the single mobile pulley, the mechanical advantage is equal to 2. That means by using this mobile pulley we are obtaining gain in force. But the disadvantage of this pulley is the effort is applied in the upward direction, which is inconvenient. So, if I use this pulley, that is mobile pulley, and this fixed pulley in combination, the disadvantage of the single fixed pulley, what is the disadvantage? The mechanical advantage is equal to 1. Yes, it is by using this pulley we are not obtaining any gain. Yes, this disadvantage is overcome in the mobile pulley. The disadvantage of movable pulley is the effort is applied in the upward direction, which we can overcome by using this pulley. So, if we are using this fixed pulley and the movable pulley in combination, then the disadvantages of both the pulley system we can overcome. Yes, next one, see the diagram of combination of pulleys. See here, the pulley P1 is the movable pulley. In the diagram, pulley P2 is a fixed pulley whose axis of rotation is fixed. See, the metal frame is connected to the rigid support. Here, the load is connected to the central metal frame, but it moves with the pulley itself. Okay. Inextensible string is connected, one end of the string is connected to the rigid support, the other end passes over the single movable pulley, the other end passes over the fixed pulley. At the free end, we are applying the effort. Here, you are applying effort in the downward direction. Yes, and by using this pulley system, you will be getting the mechanical advantage is equal to 2. The derivation is similar to that of the single movable pulley, and velocity ratio is also equal to 2. So, efficiency is equal to 1 or 100%. That is only in under ideal condition I am speaking about. Okay, we are neglecting the friction at the axle of the pulley, and we are also neglecting the mass of the movable pulley. Yes, under this condition, that is an ideal condition, the efficiency is equal to 1, because mechanical advantage is equal to velocity ratio. In that condition, the efficiency is equal to 1 or 100%. Yes, and using this pulley, the disadvantage of using the fixed pulley is overcome, and the disadvantage of using the movable pulley also, by when we are using the fixed pulley and the movable pulley in combination, the disadvantage of using only fixed pulley or only movable pulley, both are we have overcome. Okay, but in this case the mechanical advantage will continue to be 2. It acts as the force multiplier. The mechanical advantage and the velocity ratio, the value will not undergo any change in the combination of pulleys. Yes, students. Okay, next class we discuss about combination of pulleys with more number of pulleys in the system. Okay, so today's class we have discussed about single fixed pulley, next one single movable pulley, and the 2 pulleys in combination. In all the case, we have to derive the mechanical advantage, velocity ratio, and efficiency. Yes, students. Next class we discuss about more pulleys in the combination of pulleys.